Hello and welcome to another fabulous session on statistics. Today we're going to talk about discrete probability distributions. Learning objectives for today's sessions include identifying the characteristics of a probability distribution, distinguishing between discrete and continuous random variables, and computing the mean, variance, and standard deviation of a discrete probability distribution. Next, we're gonna learn about explaining the assumptions of the binomial distribution and how to use it for calculating probabilities. Finally, our objective is to learn how to explain the assumptions of a Poisson distribution and how to apply it to probability calculations. So question is, what is a probability distribution? What is a probability distribution? A probability distribution is essentially a list of all the outcomes from an experiment, along with the probability of each outcome occurring. For a valid probability distribution, there are some requirements. Okay. Number one, the probability of any given outcome must be between 0 and 1. Right? And all outcomes must be mutually exclusive. That means that no overlap between them. Finally, the sum of all probabilities must be equal to 1. Because if you think about this, when we say probability between 0 and 1, 0 means 0%, 1 means 100%. That's why, the sum of the probability of all the outcomes, right? So all the probabilities for all the outcomes, that when you add them up, they must be 100%. That's the maximum. That's the max of the range. And note that when we say 0% and 100%, they're both extremes are inclusive. So 0 less equal than P, if P is a probability, less equal than 1. So if you look at this, let's say to understand it better. So let's say we want to see how many times head shows up when we toss a coin. So on any coin, how many heads we have? One head. It's one head, one tail, right? Flip size. You're tossing a coin 3 times, 3 tosses of a coin. How many times the head shows up? So basically, you're doing it 3 times. Okay. So this table you see, it shows the possible results here, right? Possible results. What you're doing is you did it 8 times. 1, 2, 3, 4, all the way to 8. So first time you toss the coin, you have T means tail, head, H means head. So you toss the coin, it toss the first coin, right? I mean, first time you toss the coin, you got tail. Second also you got tail, and third one you got tail again. How many heads you got? None. So you put 0 here. In the second trial, okay, so you toss the coin once, tail, no head. Second one, tail, no head. And third time you did see head. So how many heads we have in this trial? 1. So you add 1 to this tally of number of heads. So you keep doing that, and you can see, you keep counting the number of H's. H means head, and you get this column here for number of heads showing up in each trial, right? So let's see how we can use this information. So we can use this information for a probability. All right, so how many discrete numbers we have for heads? So we have like a 0 and some 1s, some 2s and 3s. So basically 0, 1, 2, 3. We have 4 random numbers here, 0, 1, 2, 3. Okay. And we have to look at how many times 0 shows up in 8 trials, and how many times 1 shows up, and how many times 2 shows up, and 3 shows up. So, and we divide by the total number of trials to get the probability. So if you look at this, total trials are 8, right? So we have to look at actually how many times no head shows up, how many times 1 head shows up, how many times 2 head show up, and we divide by the total number of trials. So we have 0 shows up 1. I mean, 0 means in 1 trial we have no head. So 0 is only 1. So 1 divided by 8. So 1 shows up 3 times, 1, 2, then 3. So we have 3 divided by 8. And 2 shows up 3 times. 1, 2, 3. So 3 divided by 8. And finally 3 shows up only once. And we have 3, right? 3 is 1. So 1 divided by 8. So ratios give us a probability out of total. And as I said, no, the rule of probability is that all probabilities must add up to 1, means 100%. And this is what you see here. If you add this up here, even if you add these after decimal points, you come out to 1. But here, if you see that 8 is 8, you see the total is 8. And the numerators for every ratio, you add them up. 1 plus 3 plus 3. 4 plus 3, 7, and 7 plus 1, 8. So 8 divided by 8 and gives you 1. Even if you add these values, they will be equal to 1. So that satisfies the rule. And you can plot them, and this probability distribution can be plotted like this, where you have a number of heads, because we have discrete number of heads now. No head means 0, 1 head means 1, 2, and 3, and so on, right? And a probability we plot on y-axis, and when we plot this, we get this kind of shape. It's just like a bell-shaped curve. If we connect the tops of all the bars, you see this bell-shaped curve like that. This is called probability distribution. All right. So random variables. What are random variables? Random variables are the values that result from random experiments. So those tossing a coin, what is that? That is a random experiment, right? And there are 2 types. Random variables are 2 types. Like we have one type is a discrete random variable. Other type is continuous random variable. Now let's look at actually what is random and what is continuous. Discrete random variables. These can only assume distinct separated values that we can easily count, often coming from counting. We can count them. They are not too many. For example, number of heads in coin tosses we just saw, right? So we had okay, how no head means 0, one head means 1. If you have 2 times 2 and so on. So those are discrete random variables. We can easily count them, right? Yeah, so basically, again, so we can count them. Here's an example of that, actually, example of random variables. The Bank of Carolinas counts the number of credit cards carried by a group of customers. This table shows you the example here. The number of cards carried is the discrete random variable, right? Because we can easily count them. Somebody may have no credit card, somebody has 1, somebody has 2, and somebody has 3, and so they have more than 4 or more. And here is the probability of of each type of person. So again, when you add this up, it adds up to be 1. This kind of a situation is an example of discrete random variables. So you have like only 4 or 5 or maybe 10 random variables, but you can easily count them. Okay. Now let's look at continuous random variables. Continuous random variable, these can take an infinite number of values within a certain range. So how we measure them? These are from the measurements of, like, for example, time measurements, or another example is like a snowfall, how much snowfall in a given period, right? Snowfall, how many inches snowfall in a given period. Um, so these are hard to count, but you measure. It's like continuous. So basically, continuous random variable means like you have too many closely, tightly packed variables that if you start counting them individually, it's so hard, right? So they appear to be continuous. Okay. And it's like a, when you measure time between some, say, okay, taking 14 hours or 13 hours like this. So, and you can divide them, that time frame, into so many different tiny milliseconds or whatever unit you use. So it's continuous. Basically, it's like a flight takes 10 hours, it's continuous 10 hours. Okay. So within that 10 hours time, it's like continuous, all the variables. It's called, so when you have, if you think about this, you have like individual variables, but they are so close to each other, so they appear to be to continuous, right? Could take any value. So a flight takes, like I said, no, takes like let's say it leaves 8 a.m. So 8 a.m. means 8:01, 8:02, 8:03, 8:04, 8:05, 8:06, and 8:07. And you keep counting that. It's like so many random variables. And they are all in contiguous sequence. And that kind of situation is we call continuous random variable. Okay. Okay, so there are other terms associated with these variables. Discrete probability. We need to know those for understanding a discrete probability distribution. Okay. And the key values that we gonna talk here is a mean, variance, and standard deviation. What is the mean? Mean is also called expected value. This is the long run average of values in a probability distribution. Average. Okay, when we say expected value, how we find it? So mu is Greek symbol that's used for referring to mean value. So mu is equal to sigma. Sigma means summation, sum. Okay, within the bracket we have x times px. X is any variable value, any variable, and px is the probability of this x variable. So what you're doing is you are multiplying each variable with this probability, right? Let's say you have a 5 of these x's, five numbers. So you look at the probability of each, you multiply each number with the probability, and the products, you add them up because there's some sign in front of it, right? And you take the weighted average, and that gives you mean value, right? So a mean, this is also called expected value or mean value. Okay, so variance is denoted as a sigma. Is a sigma. This symbol is sigma, right? This is also sigma here. So a summation. This is summation symbol, but sometimes it's also called a sigma. But this sigma is different here. This sigma is not summation. It's used for it by itself is used for standard deviation. So sigma square is a variance. Variance. So what is the variance? Variance is so you this is used to describe the amount of spread, right? The spread of data, total spread of the data. Remember, we have a curve, we have a frequency, probability distribution, and all the points are spread under the curve. Okay. So it measures how much the values differ from mean. How do we find it? We subtract the mean from each value. Okay, each value x is the value of any given value. The mean is the mean of a bunch of x's. So we subtract from each value, and we do the square of that, then multiplied by probability of each of those x's. So the product, we again sum it up, and we sum the up. So this is that's how we find sigma square, which is called variance. Okay, variance. So, and when we take the square root of that, and that's what we gives us standard deviation. Standard deviation is only sigma. So if sigma square is given to us variance, we take a square root of that. It gives us a sigma. Sigma is standard deviation, which measures the spread around mean, whether it's on a left-hand side of mean or right-hand side of mean. Okay. All right, so this is an example here. So number of cars sold on Saturday has the following probability distribution. You have this car sold, 0, 1, 2, 3, 4. This shows a car sold. This is the probability of those. And again, total probability should add up to 1. So what is the probability? What is the type? What type of distribution is this? Right? And what is the variance? How many cars you expect to sell means expected value. So we need to find that. All right. So we know what it is. we need to find mu, that's mean, and we need to find other values that we are supposed to. So let's look at this. Okay, so we know that to find expected value or mean, we need to find a probability of each random variable. We have random variables like number of cars sold, 0, no cars sold, or 1, 2, 3, 4, right? It depends on how many cars sold. And we have the probability also. So what we need to do is we need to find each random variable and also find corresponding probability of that random variable. Then we multiply each number with its probability, and then when we get all the products, like for column 1 and 2, we got this in column 3, x times px. Then for second row, we got 0.2 here, and so on. And so we got the product x plus px. And you know that mean or sigma, mu is equal to sum of all the products. So we got all the products here, we add them up. So mu is 2.1 here. And total probability you add up is should be of 1, and it is 1. And this is example of our discrete probability distribution. You see there are only like 5 possibilities here. So they are discrete, can easily count them. Okay. Variance. So how we find variance? Variance, we know this is sigma square. And we find that it's the same kind of procedure here. We have the sum of the products. But the products here we have, it's not x px, but we have x minus mu. This is what variance, how variance is calculated here. See the variance here, x minus mu. So x minus mu is mu. So subtract mean from each random variable and square it, and then multiply that. So we can have a column dedicated for that, right? And we multiply each random variable with the probability of that random variable with the x minus mu square value. So we have this value for first element here, and we have probability here 0.1. We multiply this with this, and we get this value, and we repeat this for all these numbers. And but we add them up because it's sum of all these products. The sigma square is 1.290. This is a variance in this situation. And how we find standard deviation? We have to take a square root of sigma square root, and that will give us the standard deviation. All right. So another type of now this is another form of a discrete probability distribution called binomial probability distribution. As you know, binomial it has only two values, two outcomes. That's why called binomial. Only two outcomes, either success or failure, or either true or false, like a Boolean type of relationship, right? Either 0 or 1, just like a binary. So, and they are mutually exclusive, of course, because you can't have a success and failure at the same time. They are mutually exclusive. If you have a success, then there is no that, then it's not failure, right? If something is true, it's not false. So two distinct outcomes, not mutually exclusive. Okay. So number of trials is fixed and known. So we need to know the number of trials also. And third is like probability of success remains the same for each trial. Either it's because either you have a success or failure, the probability is same. It's 50-50. Finally, each trial is independent of others. Right? It doesn't mean that if you had success in this trial, you will have success again in next trial. It could be failure. right? It's 50-50%. So probability is again always 50% because you have two outcomes, either this or that. This example shows you that probability of if some family has two children, both boys, the probability of third birth being still being a boy is still 50%, because when child is born, that child is either girl or boy, 50-50%. Okay. So formula for that binomial distribution is this actually. So Px is equal to NCx pi x pi superscript in parentheses 1 minus pi and then to the power n minus x. And so what it stands for? C is a combination of x successes, n is number of trials, x is number of successes. Pi is not the pi value you know from math, like 22/7, not like that, which is equal to 3.12142. But pi here is a probability of successes given to us. Okay, so we use this, the way we use this for x is equal to 0, 1. So x can take, any number, like any integer. X is equal to 0, 1. L means, L here stands for, like when we say in English, so on. When we say 0, 1, 2, 3, 4, so on, all the way to n. N is the just a random variable that say, hey, n can be any value in the future, right? So x is equal to 0, 1. L means 2, 3, 4, 5, 6, 7. That means it's the same pattern of numbers. X can assume this value infinitely, it depends on like a 0, 1, 2, 3, 4, 5, 6. L just a symbol showing that and so on, and this same pattern continues. And in binomial probability distribution, mean is found by the product of n and pi, and variance is n pi in parentheses 1 minus pi. So these are the formulas to use. Let's see the application of this formula. So here, this is example here where creditcards.com, they say 28% of purchase at coffee shops were made with the credit card. And you got to calculate something here, like for 10 randomly selected purchases at Starbucks on the corner of some place. What is the probability that exactly one of the purchases were made with a credit card, right? So we need to look at the probability of one of the purchases to make sure it's credit card. And then we also need to find what's the probability distribution of the number of purchases made with a credit card, probability distribution overall. Then we find the probability of that 6 or more purchases were out of 10 were made with the credit card. And then we need to look at the mean and standard deviation. All right, so let's see how we can do that. All right, so formula we know about binomial distribution is like this one, right? It's all based on same formula. So C here is 28% because pi is 28% because pi is the probability. So pi, you can see pi value, you can see this relationship is 28, right? So this is a formula 10C1, and the formula when we put this put these values in a formula, we get this 0.1456, which maps to 1. Okay, random variable 1. That means because they're asking us, okay, this one. What's the probability that exactly one of the purchases were made with the credit card? Okay, so what we found this probability. The probability is 0.1456. This. So for one credit card usage. And then we can use this formula to find the probability for, if somebody has used the credit card 2 times, 3 times, 4 times, 5 times, the same formula we can apply to find various values, right? As more and more, as the number of credit card users go up, and see the probability keeps going down. Okay, we can find mean and variance. We know the formulas, n pi. So n is n is a 10 randomly selected purchases. That's the number of trials. Okay, so n pi we got 2.8 mean variance. This formula we have n pi 1 minus pi. We got this one, and take a square root of that because the sigma, this is sigma square. Standard deviation is a sigma. So sigma square root of that equals with sigma is 1.42. Okay, and we can build this table with by finding values like probability. This is the expected value. This is the variance x minus mu square, and we can add all the products, and then we have got 2.016. And this is exactly, basically, this is how we verify that. And the variance here with the formula is 2.016. If we do like step by step, by finding the probabilities for each and taking the product, and if we this is the expected value, and it's like it's a sum of all the products of probability and random variables. But variance is we have to find x minus mu square for each variable, and then you add the products for all the variables, and even by doing this lengthy procedure, we still got the same thing, 2.016, as we got with this formula. In any statistics book, you will find on the back of the book distribution tables, probability distribution tables. Some, in complex problems, no, you don't have to actually do the manual computation unless somebody asks you to do that. You can simply look into the tables pre-made for you. On one side, like here, you have n is equal to 6 probability. The probability for that is given the table. N value is given here, x pi, so it's given here. You can go through the table and find appropriate value. Now you can also look at the shapes when you plot those values, and different shapes are available in the books. Values of n and pi, for various values of n and pi, you can have a general idea how the distribution is, right? So again, these are available to you in the textbooks. If you see in the back of the book. So these are generally observed behavior of probability distribution. They can give you idea if for certain values how the shape is. Okay. Okay, so the last distribution type that we're going to talk about is, this is another form of discrete probability distribution. It's called Poisson probability distribution. So the Poisson probability distribution helps in modeling the number of events occurring over a specific interval, like a time, distance interval, or area, and any interval like that. And there are some assumptions for that. Assumptions: the probability is proportional to the length of the interval. Number one. Number two, the intervals are independent of one another. So we're gonna look at some examples. So we can look at some examples here. Let's see. These examples are here. Distribution of errors in data entry, the number of accidents on some freeway I-75 during a 3-month period, right? So the formula for that is this formula here: Px is equal to mu power x, E power minus mu. E is a constant value 2.71828, and divided by this one is x factorial. X is a random variable. Okay, mu is a mean value. You know that mu is a mean value. E is given to us, is fixed, and x can take any value like 0, 1, 2, 3, 4, 5, so on. and mu formula is n pi, just like a binomial, and variance is also n pi in this case, sigma square. So once we have these formulas, we can simplify it and use it, right? N is number of trials, pi is the probability of success. So now here is the example here. Budget Airlines is a seasonal airline that operates flights from Myrtle Beach, Southern California, Southern Carolina, to various cities in the Northeast. Recently, Budget has been concerned about number of lost bags. So somebody from analytics department, they looked into the issue, and she found that she looked at a sample of 500 flights and found that 20 bags were lost. So what is the mean number of bags lost per flight, and what is the likelihood that no bags are lost on a flight? So we need to look at that. We can use Poisson probability distribution for that. Okay, so mu means, okay, we know that 20 out of 20 bags were lost on 500 flights. So what is the mean? Mean is like 20 divided by 500 is 0.04. The probability of no bags lost, we can simply use the formula. We know the formula for Poisson distribution here, and where in this case the value of x is 0, because no bags lost means x is 0, right? X is 0, so we can put mu, we know that 0.04, and when you substitute these values in a relationship, and we find that we get 0.9608, and we can look for like any number of bags lost. One bag lost, two bags lost, 3, 4, 5, 6, and so on and so on, just by using this formula. Okay. And just like a binomial distribution or any other distribution, if you grab any textbook or reference book on statistics, you can find in the back of the book various tables giving you values for various types of distributions. So Poisson distribution, also there are tables available for your reference. Again, we need a value of x and mu in this case. So for various x's, we have the various values of mu, and we can simply find locate the cell that refers to our combination of x and mu, and that is our value for that probability. All right, so that was a brief discussion on discrete probability distributions. I hope you enjoyed it. Thank you for your attention, and looking forward to talking to you in another session like this. If you like it, please do give your feedback, and also knowledge multiplies by sharing. So share with your other, your contacts or other students, your peers, anybody who can who is interested in learning this kind of information. Thank you, and I'll talk to you later. Thank you very much. Bye.